Hello, my name is Kainson Mounonier, and in this video I'm going to explain graphically this time about baseband modulators. This is actually a follow-up of the first video I uploaded on baseband modulator, where I explained what happens when a bit stream of ones and zeros is received by the modulator. But now we'll go to the whiteboard to see exactly what happens, or the kind of waveform generated when beats are received by the modulators. Just a recap, you see on the slide here, you see the various types of baseband modulators, the three categories. We have the, let me get this annotation pen. We have the NRZ modulator, RZ modulator, and phase-encoded modulators. NRZ, we have two types, NRZL. Then we have NRZM, RZ modulators, unipolar RZ, bipolar RZ, phase-encoded modulators, Manchester encoding and Euler encoding. RZ means return to zero, NRZ, non-return to zero. So let's move on to see exactly what happens when a bit stream is received by different types of modulators. So we start from the first one, this NRZ modulators. That is what we are going to discuss next. Okay, here we have RZ modulators. In RZ modulators, we have this first one, NRZL. Now, what happens when a bit stream is received? If it is a 1, it generates a positive voltage for the time duration Tb. If it's a 0, a negative voltage, and here you have minus V for the time duration of Tb. And this is a waveform generated when a bit stream 101100 is received. So you have this, it goes this way, comes down, go up, stays to duration here, comes down 00. I think this is very clear, and this is NRZL. So non-return to zero, as you can see, the waveform never stays at 0. It always goes either a positive voltage or a negative voltage there. Then we have NRZM. Here we have a 1 is received. It can be a positive voltage, as you can see, for a 1, and a negative voltage for a 0. But this is not the main point. The difference between the NRZL and the NRZM is that when a 1 coming, we have a change in the voltage level from either plus V to minus V, and if a 0 comes in, there is no change. So initially, the initial voltage might either be a plus V or a minus V, but when a 1 is received, there's a change. So here we have initially at 0 volts, the 1 is received and it goes up to positive. A 0 is received, nothing happens, it stays at 0. A 1 is received, it goes down and stays. A 1 is received, it changes, it stays. 0 is received, nothing happens. 0 is received, nothing happens, it stays just there. I hope this is clear. We want to move to the next one, the RZ modulator. As you know, I explained in my previous video, the RZ modulator makes sure that the waveform is generated that stays at a 0 volts for half of the time duration. So now, for unipolar RZ, what happens? Let's say a 1 is received, we have the signal stays at plus V for half the time, and 0 for half the time. So we have this plus V, or it stays here at 0 for half the time. So this interval here is half TB, or TB over 2. So that is what happens when a 1 is received. If a 0 is received, it stays just there at 0 volts, as you can see here. So what happens when a bit stream 101100 is received by the unipolar return to 0? What happens? 1 it stays at plus V half the time, at 0 half the time. 0 stays at 0 throughout. Then we'll have 1 is received, it stays plus V as half of the time, stays at 0 half of the time. 1 plus half of the time, 0 half of the time. And 0 is received, it stays just there at 0 throughout the bit duration or the interval. Okay, so we move to the next one, the bipolar RZ. Here we have a 1 is received, it stays at plus V. A positive voltage is generated for half the time duration and a 0 for half the time duration. For a 0 received, it stays at a negative voltage for half the time duration and a 0 for half the time duration. So it's more like an inversion of what happens when a 1 is received. That is what happens when a 0 is received. So for a bit stream of 101100, we have this. It stays plus V half of the time, 0 half of the time. For 0 half, it stays at minus V half the time, and here it stays at 0 half of the time. And just like that, the bipolar RZ modulator. So we move to the next one, the phase-encoded modulators. The phase-encoded modulators. Here we have a signal is generated for a bit that is received. But if it's a 1, it goes from positive to 0. Okay? If it's a 0, it goes from 0 to positive. That is from a positive voltage to 0 for a 1, and for a 0 to a positive voltage for a 0 bit. So for the bit stream 101100, we have 1, it stays a positive voltage, there 0 for 1, then for 0, from 0 it goes up to a positive voltage. For 1, from positive it goes down there to a 0. For 1, positive to 0. For 0, 0 to positive voltage. So that is what happens there for Manchester encoding phase-encoded modulator. Then we have the Miller encoded modulator here. For 1, it might be a positive voltage or a negative voltage. For a 0, the same, it can be a positive voltage or a negative one. But the principle of Miller encoding is simple. There must be a change in voltage level for each new bit that is received. So for 1, 0, there is a change. Here 0 here, it changes down. A new bit stream, it changes. So for the Miller encoded modulators, there is always a change in the signal level for each new bit that is received. That is just the principle, but for when a new bit comes in, it can either be any voltage level, positive or negative or 0. But for a new bit coming in, there must be a change in the voltage level. So this is here we wrap it up on our discussion of baseband modulators, and in my next video I'll now go into explanation of the bandpass modulator. That is the second class of modulators in use today, and I hope this video has been informative for you, and I'd like you to click on the like button there, and maybe you comment on my video, share with your friends, and subscribe to my channel. And always expect great videos where you can always learn telecoms topics. I try to explain as as much as I can in a very easy way for everybody to understand. So once again, my name is Kainson Monoye, and I would like to thank you for viewing.